information vite!
Heute Morgen um 8:13 Uhr Ortszeit geriet die Europäische Union unter Beschuss von Reaper-Kampfhubschraubern.
L'attaque globale, on va contre les forces hostiles.
There you have it, Magnet. The Reapers are back. Our commander was right.
How are we going to stop them?
I really don't know. But I have an idea. The Reapers are using high-powered and high-energy lasers. We can use their own technology against them. Using your name, the great Admiral Xavier Ortiz, I think I will be able to build a laser strong enough to destroy these things.
I'm not a god about hand machine help, but I'll try my best. What do you need?
I need an active medium, something that will produce a lot of mass spec. Something that can produce high photon output.
We need a large shuttle. Something on the scale of a dreadnought. A powerful active material. Preferably element 0. And a power source large enough for our purposes. The shuttle serves as a container, and the active material produces the lasing effect. We need a large mass spec generator to serve as the power source. When the current goes through the active medium, its electrons become excited. When the atoms in the active medium become excited, its electrons move to a higher energy state. I'll spare you the quantum mechanics and intradimensional electromagnetic theory, but the electrons basically always want to return to their original ground state. In order to do so, it needs to release the extra energy it procured, and to do so, it needs to emit a photon.
That's just the theory behind a flashlight. How is a laser any different?
Well, you see, a laser is both collimated and coherent.
The term laser stands for light amplification through stimulated emission radiation. What makes a laser different is that it uses stimulated emission as opposed to the spontaneous emission of a flashlight. What this means is that the electron gets interrupted in its excited state by another photon. This forces it to emit two photons, the incoming photon and the photon that would have been released during spontaneous emission. The advantage of this is that when these two photons are released, they are both coherent and collimated.
What do you mean by collimated and coherent?
Coherent means that the photons are in phase, meaning that the peaks and the troughs of the light waves correspond to one another. Collimated photons move in the same direction. This allows for a focused beam of high-energy light, similar to that which has been used against us by the Reapers, which we will be able to use against them.
No,
I see that your illustration shows the atom as having more than one possible excited state. Why is this? Wouldn't it be more efficient if the atoms were to only have one excited state?
That would have been a sound theory. However, the reason for this is because we want it collimated, but in a certain direction. We want all of the photons be going in one direction.
If there were only two energy states, an excited state and a ground state, the photons would still be collimated, but in random directions. What the third state allows us to do is set up a placeholder for uncollimated light. By using element 0 and the mass effect, we can change the lifespan of the different energy states. That is, how long the atom has before it spontaneously emits a photon in a given energy level. We can give the higher energy state a short lifespan so that there will be a constant spontaneous emission coming from that energy state. In the lower excited states, we can set up a longer lifespan, which favors stimulated emission. Because only one type of photon is emitted as a result of stimulated radiation, they will all be collimated in the same direction. Because only one type of photon is emitted as a result of stimulated radiation, they will all be collimated in the same direction. Any such photons that go in a different direction will bounce off mirrors and leave the container. Desired photons, however, will all travel perpendicular to the mirror setup. We can then put an opening in the mirrors and release the laser beam.
Specifically laser. Now, Commander, in theory, this will work perfectly fine. God damn it, Tazwar! Chowdhury! Damn it! Stop drawing, Tazwar Chowdhury!
Yeah. Oh, God. Give me a second, sir. Just finishing up something here.
Damn it, Tazwar! This isn't right. You're a research student for a reason. Don't doodle. This is very important.
Commander, this is quite proud. You'll have to wait before I show you.
No, Admiral. This sounds all good in theory. But the mass effect field that we would need to generate this, way beyond everything I've ever seen. Enough to destroy the Reapers. We could destroy the world. Destroy the world? It's too powerful. Chowdhury, give me that. Stop!
Dr. Shimmer, I believe I have a solution to your little problem. Here's what I've been working on.
Admiral, do you see it?
Yes.
Admiral, I think this can work. Admiral, can we build it?
Yes, we can!
Humanity still has hope yet.